I'm going to look at what can we do with logs. So at this point, you've probably been looking at logarithms, knowing how to switch from logs to exponents, exponents to logs, getting a basic understanding of kind of what a log is. So what I want to look at is what exactly can you do with a log? What is its purpose? How does it help us? And the best way for me to draw that out is to look at solving some basic equations where we can use logs. The idea is this: when I teach solving equations meaning you're trying to get like a variable like x by itself, you're pretty much working PEMDAS backwards. You're trying to isolate or get x all alone. The tough question that comes with that is, well, what pieces do you remove and when? Well, to know the order in which you need to move pieces out of the way, you're going to do PEMDAS backwards. Now, think of PEMDAS as kind of a toolbox of different things you can do to try and get x by itself. At a young age, you learned about addition and subtraction and how those are opposites of each other, the opposite of addition and subtraction. When I say opposites, you can think of inverses. They're inverses of each other. Then you dealt with multiplication and division. The opposite of multiplying is dividing. Then we figured out exponents. If something is squared, we use a square root. If something is to the third power, we use a third root. And then we dealt with parentheses. Okay, so you've been expanding this toolbox of inverses, things that undo each other, things that are opposites. So what we add to this list and to this toolbox is logs. Now, where logs are going to fall is they're going to fall under exponents. Logs are essentially exponents there. And we're going to find out that the opposite of a log is some sort of exponent with the same base. The opposite of logs is an exponent of the same base. So here we go. Solve the following. Log base 4 of x plus 9 plus 2 equals 4. The idea is the x is on the left side, so I'm worried about everything on the left side of this equal sign. I don't really care about that 4. Okay, I'm worried about everything that's on the side with x. So what I do is I go through and think about what are all the pieces that I have on the left side here for x. So we have a log with a base of 4. And we just talked about how a log is an exponent. So I do have an e piece there. Then I do have an x plus 9. A lot of people are going to look at that plus 9 and say, hey, isn't that addition? Which, I mean, it is. That is an addition by 9. But if you look at it, it is inside of parentheses. That is an x plus 9 inside of parentheses. So we have our parentheses there. And then we have this plus 2 on the back, which is essentially by itself. And that is addition. So if I want to get x by itself, I need to work PEMDAS backwards. So I need to get rid of the addition first, then the exponents, then the parentheses. So the opposite or the inverse of adding 2 is subtracting 2. Great, start with that. So you get a log base 4 of x plus 9. And on the right side, 4 minus 2, which is 2. After that, so I've taken rid of the addition, I need to deal with the exponents. And this one's a little bit hard to kind of comprehend what's going on. I have a log with a base of 4. To get rid of a log with a base of 4, what I'm going to use is an exponent with the same base. To get rid of a log with a base of 4, use an exponent with a base of 4. So what's going to happen is I'm going to do a base of 4, and that entire log piece is now up in the exponent. So I have a 4 with an exponent of log base 4 of x plus 9. Base, exponent. If I do that on one side, I got to do it on the other. Base of 4, the 2 is now an exponent. What happens there is when you have an exponent with a base of 4 and a log with a base of 4, those are inverses, so they are gone. You just get a plain old x plus 9. And on the right side, we have 4 squared, which is 16. So I've taken care of the exponent piece there. Again, the kind of new piece here is the opposite of a log with a base 4 is an exponent with a base of 4. And you'll see here in a second, the opposite of an exponent with a base of whatever is a log with the same base. You'll see that in our second one. Finally, we can deal with what's inside the parentheses, get rid of that plus 9 by doing minus 9, and we get x equals 7. Okay, so I'm going to show you the opposite way here. What we're going to do there is we're going to start with exponents, or sorry, we're in exponential form. So it's the same idea of PEMDAS backwards. We do have this 2 out front. That is multiplication. I'm going to use the right side here. That 2 is multiplication. That 10 is a base to an exponent, so I do have a base there. And there is a plus 2, which a lot of people are like, oh, it's obviously addition. But it's up in the exponent with that x. That's actually grouped up there with that x. So that is a grouping of x plus 2, therefore it's parentheses. So if I'm focusing on the left side where x is, working PEMDAS backwards, I got to get rid of the multiplication first, then deal with the exponent, then I can deal with the parentheses. The opposite, or the inverse of multiplying by 2 is dividing by 2. So those inverses there are gone. We get a base of 10 and an x plus 2. On the right side, 6 divided by 2 is 3. Next, I got to get rid of this exponent base of 10. If you want to give an exponential base of 10, you're going to use a log with a base of 10. So we're going to do a log base 10. If I do a log with a base 10 over here, I got to do a log with a base of 10 over there, okay? So if you have an exponent with a base, match it with a log of the same base. These are now inverses. See you later. We get an x plus 2. On the right side, we have a log base 10 of 3. That is the common log. So that really is just a log of 3, which, remember, you can do that in a calculator. Log of 3 is, oh my goodness, 0.47712, etc., etc., etc. I'm going to round that to 3 decimal places, 0.477. Great. Finally, we got to work up in that exponent. It comes down. We have an x plus 2. Subtract the 2. Subtract the 2. 0.477, because that's what I rounded to. Minus 2 is negative 1.523. Okay. And that's what we can do with logs. Logs help us get rid of exponential bases. Exponential bases help us get rid of logs. So we're just adding to those tools of things we can use to solve equations. One other quick comment I want to make on here, and we'll wrap it up, is a lot of people do look at these and they're like, well, can't we just switch from, I teach you how to go from logs to exponent form, exponent to log form, bacon and eggs, ring a bell. That is happening here on this step. When we have a log base 4 of x plus 9 equals 2, what actually has happened here is we are in log form. We switch that to exponential form. 4 raised to the second power is x plus 9, which we simplified this to 16. I'm switching from logs to exponents there. And down here, when I was in exponential form, we switched to logs. So that is another way that this stuff is taught. I don't really like that so much because we're going to use more of this as we progress in the chapter. So I like to show you, hey, you're just adding another tool to kind of your toolbox here. The opposite of logs is using an exponent with the same base. When you have an exponent with a base that's in the way, use logs to get rid of that base. And that is what we can do with logs.